We just had the case predictive maintenance, which is a very huge cluster for the manufacturing topic or for the make processes. And if you think about computer vision itself, it's also a very huge topic. It's even a study by its own within computer science. Within the manufacturing process, computer vision is mainly used for enhanced quality. So let's have a look on the vast variety of computer vision cases or AI cases within the manufacturing process. So let's start with the classical vision-guided robotics. Every kind of robotic systems have a vision system in place. Think about robot arms, pick place. So you need here the vision systems. In images, you can detect anomalies, irregularities during the assembly process. So you can do defect reductions, of course, by autonomous inspection of many items. So on the left side, a classical picture are all items they are placed. Their vision systems, it's called inline vision systems, to control every aspect of your productions. So this vision cases are more towards the assembly or the make processes itself. The next part is maybe more to finishing a product, like for example, the left side also a good article on some deep learning cases on identifying the quality control in the manufacturing, so final quality control. For example, packaging inspection would be one of these big cases. So you look if all packages are correct in color, size, and this can be done wonderful with computer vision systems. Nearly all products have barcodes or text labels on top, so these are scanned to look if the correct barcode or if the correct labels are on it, tracking the label itself, and then see if these are misplaced. For the food industry or beverage industry, this is one of the big topics, or also in the pharma industry. So these are the most classical big cases, and there are many more. If we speak about vision systems itself, it's getting also way more important now for the safety aspect in the production cases. So to identify hazardous condition monitoring, so maybe it detects smoke or other hazardous leakages. We have emergency response detections, alerts when by moving objects, detecting unsafe behavior, so to improve the workplace safety overall. Or if you really go to the personal protective equipment, so think about the hard hats to detect if you have to wear it. We had as well the cases in COVID, do you wearing a mask? So there are many cases. You cannot list all cases here. It's for sure a topic where AI gets way more penetrating now into the topics itself. Classical vision systems are really developed since 30-40 years and are really good. With new AI vision systems, we can increase often even the problem space or the quality detection overall. Here is one example in the Nature article, and at least in this paper they claim that the new machine learning application is more accurate than previous method. Whenever you go into this topic of quality and vision, always go step by step. Start with classical vision systems because they are approved and often good enough. Once you cannot solve this with classical systems, you can extend it to AI-based systems. But always remember, if you go to machine learning or AI-based systems, you need a lot of pictures, or you really need a vast amount of pictures to really improve the quality. Of course, this was not an in-depth introduction of the vision systems. Again, it's just too big. I think in some follow-up lectures or in other lectures, I will explain more in depth where to look on within these vision systems.